Hello friends, it's me again. This video I'm going to try to be more enthusiastic because I have a friend that keeps mocking me. Um, so what we got for this video is just going through and looking at everything that comes in the kit that you guys are getting for the class. It's the Spark Fun, I switch views here. The Spark Fun Inventors Kit. The bookstore might mark it up a little bit. They order in bulk and then they usually put a few extra dollars on just to cover the cost of staffing the bookstore so you guys can get it more easily. As I mentioned, or I will mention in a video, these are kind of shooting these out of order because there was low stock on these. So I had to shoot other videos before this one. If you check online, it's actually not easy to get these kits all the time. So it's a good thing that the bookstore was able to order in bulk and get enough for everybody. So what I'm going to do in this video, if I can go back to this, is I'm going to go through and show you everything that's in there and point out, hopefully talk to you about when we'll be able to use a lot of these things. Wheels, which will hook up to, we pull out the other bright yellow thing, a couple DC motors. So these are geared DC motors. These actually plug directly, these white parts plug directly into the back of these wheels. So hopefully week 2 we'll be able to have something drive around a little bit. What's most important is the thing that's going to drive everything, the Arduino itself. And in there, again, in one of the other videos, I talk about the different boards you might have got. This particular kit comes with a genuine Arduino board. They all are effectively a known quantity by now. The only reason you get a bad one is if you have someone that did not take the time to manufacture it very well or solder all the connections. So that's the Arduino board itself. You get a tiny screwdriver, which is new this year, which should come in handy. Battery pack, which if you want to write anything in C, C++, you'll be able to have it operate remotely. You don't need to keep it connected to your computer. If you're just programming in MATLAB, which is entirely okay for this quarter, then battery pack will help us power the motors and the servos, which I showed you the servo or the motors. USB cable to connect your board to your computer. Where's the servo? There's a bag with a bunch of small things. This is the servo. It's very small hobby type servo, not super strong. They are easy to burn out and also very easy to break the gears on. Don't expect it to be able to lift or move a large object. They do break fairly easily, at least this size servo. And then also in that same bag, we've got a potentiometer, which we'll look at in week 2, buzzer, which I'm not sure which week we'll be able to get to that. Hopefully not too long. Photosensitive resistor, or a photoresistor. This actually changes its resistance based on the amount of incoming light. A simple switch, a red, green, blue LED, and then some different colored push button switches. What else do we have? Bunch of resistors. These again are what will help us restrict or help prevent too much current flowing through the wires and the components that we put together in our circuits. A bunch of jumper wires. These are super handy, also super infuriating to work with. Most of the circuits, at least the more complex ones that we'll create, end up looking like a rat's nest because these things are way too long for most scenarios, but they work. This is, so single-sided tape with Velcro. And this is how we're going to put together our robot or our little rover object. So this is going to go on the bottom of this large black plate, which has 2 tiny screws. Don't lose those. So this is where your Arduino board will sit. You get the right orientation here. I probably need to pop that out of there. I feel like I'm going to break this. That'd be good. Oh, there we go. All right. Don't be scared. I don't know if that's supposed to be on there. I don't think so. That would work better. So that'll go right in there. And then on the other side, I guess this is for if you don't want to use the baseboard, a breadboard, which we'll use to construct most of our circuits. A force sensitive resistor, which we'll get to in week 2 again, with most of the other, like the potentiometer, the should have a temperature sensor around here somewhere, and then the photoresistor, a small LCD or character screen. So we'll be able to eventually hook this up. This would probably be later on, more towards the week 6-7 time frame, where we're doing stepper motor, driving stepper motors, and then a bunch of LEDs. So light emitting diodes, which we'll get to these right away in week 1, and then we'll use them throughout the term. No, there's a temperature sensor in here somewhere. There should be. Guess I got shortchanged. I don't think I brought up the motor driver, which will drive our DC motors, which is an improvement over last year and the years before. No temperature sensor. What? Shenanigans. Look at that. That's the temperature sensor right there. Where's my temperature sensor? Huh. Well, it's not like I don't have 5 others, but that's disconcerting and frustrating. Oh, found one more thing. Ultrasonic sensor, distance sensor. Oh, there we go. We'll be able to use this again. Hopefully, I'm not sure. This is a new one this year. We'll have to figure out where we can fit that in. I'm going to pause while I search for the temperature sensor. That was not long. Found it. So the good thing about this year, oh, let's switch back to the other view. There we go. The good thing about this year is this guy, last year we had some transistors to help us drive the motors, and they looked pretty much identical to the temperature sensors. And funny thing, if you plug the temperature sensor in the same way as the transistor, it gets really hot and then it starts smoking. So there have in previous years been burned fingers and small puffs of smoke coming out of people's boards. Hopefully we don't have that this year, because we've got a temperature sensor and separately a motor driver board, which is very different looking than the temperature sensor. But that's most of the components. Week 1, LEDs and push buttons. Week 2, sensors like the temperature sensor, the photoresistor, the potentiometer, the force sensitive resistor. Week 3, we'll start to look at servos. Oh, sorry, week 2 is also DC motors. Week 3 is starting to work with servos, and then week 3 gets into using multiple servos, and that's when we'll start using one of the simulators I built a little more heavily. Week 4 is really focused on a simulator version of a servo-driven robot arm that we have in the lab. Week 5 and 6 will be, or around that time frame, will be midterm project. After the midterm project, then we'll focus in on stepper motors, which we don't have any stepper motors with the kit, but they are super fun to use. I'll be able to show you some examples. Using actual stepper motors and the drivers that go along with them. I'll make a couple recommendations on ones you can get just off of Amazon or something similar. Pretty low cost. They're usually like $10 a piece, and then the circuitry to drive them is about the same. And then after that, we'll have to see how it goes, because I'm also working on simulators. Try to incorporate some of the other things like the LCD screen and the ultrasonic sensor, because those seem like fun. And we'll have to do the buzzer pretty early on, because nothing says fun like really annoying roommates. That's it. Probably worst unboxing video you've ever seen, but I was enthusiastic.